Hello everyone, I'm Inda from Srinivasan Institute of Technology. I am studying second year in Computer Science and Engineering, the specialization of Artificial Intelligence, and this is the subject of a database management system, and my bearing roll number is 2340183357 and the subject code is 23CSE302, and my topic is about normal forms based on functional dependence. This is the outlet of the topic: introduction, definition of normal forms, functional dependency, first normal form, second normal form, third normal form, bicycode normal form, fourth normal form, fifth normal form, importance of normal form, advantages and disadvantages, summary and conclusion. This is the introduction to normal forms. Normal forms are guidelines for structuring database to reduce redundancy. They are primarily based on the functional dependency between attributes. Understanding normal forms is crucial for designing efficient and reliable databases. Definition of normal forms. A relation is in a particular normal form of which satisfies certain normalization properties. There are several normal forms. First NF, second NF, third NF, BCNF is also known as Boise code normal form, 4NF, 5NF. Functional dependency explained. A functional dependency is a relationship between two sets of attributes in a relation. It indicates that the value of one attribute determines the value of another. Notation for functional dependency is often expressed as x tends to y, where x and y are the attributes, and this is the diagram of the dependency. Here we can see that in the first full functions or dependencies, and the second one is here we can see transitive dependencies and the full function dependencies. Here we can the third one sees here. First NF, first normal form. A relation is in one NF if all its attributes contain only atomic or invisible values. First normal form eliminates the nested relations by turning them into separate top-level relation associated with the parent row through foreign key rather than through direct containment. There are be repeating groups to array in the table, and this is the here as we can see the example of the first NF. And here first table we can see the student name, student phone, student state and student country, and this is the conversion of the first normal form. In the first conversion of this normal form we can see here student name, student phone, student state, student country, but we can see some changes in the first normal form to the general table. And this is the another topic, another points of the first normal form. Achieving 1NF eliminates issues related to multi-valued attributes. It increases the flexibility and data dependency and to simplify the data language. In 1NF ensures that the data in a table is stored in a simple organized manner where which column contains only one value and there are no repeating groups, and this is the example of the first NF also. Look after it. Second normal form. A relation is in 2NF if it is in 1NF and all non-key attributes are fully functionally dependent on the primary key. This means that no non-key attribute should depend on a part of a composite primary key. 2NF eliminates the partial dependencies and helps the reduce redundancy, and this is the example for the second NF. And here we can see the ID, last name, ID proof, grade. And in second NF we will divide the table. Here we can see the ID and the last name, and the second one is the ID professor and professor ID and professor name. In third table we can see the grades of both the students and the professor. These are some points of the 2NF. Second normal form is a concept that ensures the integrity and efficiency of a relational database structure. A relation is considered to be in 2NF if it meets following two conditions, and these are the two rules of the 2NF. It is in first normal form. It does not have any partial dependency. Third normal form. A relation is in 3NF if it is in 2NF and no transitive dependencies exist. This means no non-key attribute should depend on another non-key attribute. Achieving 3NF further reduces redundancy and improving data integrity. 3NF uses a set of rules. It ensures that each table has unique identifier called a primary key and that all column values are consistent data type. 3NF is a database schema design approaching for relational database which uses normalizing principles to reduce the duplicate of data, ensure referential integrity, and simplify the data management. This is the 2NF to 3NF example, and here we can see the 2NF table first here, and how the 2NF table changes to the 3NF. Here we can see that this in 2NF module department and lecturer, and in 3NF here we can see a lecturer and department, and separate we can see here the separate table for the module and the lecturer. And the voice code normal form, BCNF. A relation is in BCNF if it is in a 3NF and every determinant is a candidate key. This structure from resolves anomalies caused by the functional dependencies involving non-key attributes. BCNF is particularly useful for complex database with multiple candidate keys. Voice code normal form, an advanced version of the 3NF which is little more strict. Rules for the BCNF is the table should be in the 3NF. X should be a super key for every functional dependency of FD. X is tends to Y in a given relation. And this is the some points and examples of the voice code normal form. Relation R with the FD's F in BCNF if for all X tends to A in F plus. In the other words, R is in BCNF if the only non-trivial FD that hold over R key constraints. And this is the fourth normal form. A relation is in 4NF if it is in BCNF has no multi-value dependencies. Multi-value dependencies occurs when one attribute determines multiple values of another attribute. Achieving 4NF helps eliminate redundancy caused by such dependencies. The 4NF is a level of database normalization where there are no non-trivial multi-value dependencies other than a candidate key. It builds on the first three normal forms 1NF, 2NF, 3NF, and the Boise code normal form. Here the fourth normal form can build the first three normal forms, which are one normal form, two normal form, three normal form, and also the Boise code. This is the examples of the fourth normal form. Here we can see the table of the fourth normal form, employee name, skills, and language, and this is the conversion of the fourth normal form where we can see that employee name, skills, and another table of employee name and language. And this is the fifth normal form. A relation is in 5NF if it is in 4NF and cannot be decomposed into smaller relations without losing information. This is also known as project join normal form. 5NF addresses complex scenarios where multiple relationships exist between attributes. 5NF is satisfied when all the tables are broken into as many tables as possible in order to avoid redundancy. 5NF gets satisfied when the table is broken down into as many parts as possible to avoid the data redundancy. And this is the example of the fifth normal form. Here we can see the tables of the relation that have no joint dependencies, property item suppliers, the illegal state, and another one is the property item supplies legal state. Importance of normal form. Normal form plays a vital role in minimizing data redundancy and improving data integrity. They facilitate easier maintenance and update to the database structure. Following normal forms can lead to better performance in inquiring and reporting. It maintains the integrity of dependencies between attributes and relations. Advantages of normal form. Reduces redundant data, provides data consistency within the database, more flexible database design, higher database security, better and quicker execution, greater overall database organization. Disadvantages of normal form. You cannot start building the database before knowing that the user needs. The performance degrades when normalizing the relation to higher normal from that is 4NF, 5NF. It is very time consuming and difficult to normalize relations of higher degree. Careless decomposition may lead to bad database design leading to serious problems. Summary and the best practice of the normal forms are: always aim for the least 3NF during database design for optimal performance. Regularly analyze functional dependencies to identify potential normalization issues. Normalize data while considering performances trade-offs based on applications needs. And this is the sum of the picture or example of this summary or for the best practice. Conclusion. A functional dependency occurs when one attribute uniquely determines another attribute within a relation, an essential process for removing redundancy and optimizing database storage. BCNF Boise code normal forms are structured around ensuring the attributes in a relations or dependency on a primary key in a way that maintain data integrity. Thank you for your attention. Thank you for listening whole my video record, and thank you for giving this opportunity. Thank you so much.